All right, continuing on. Local and absolute extrema. Extrema, that is just a fancy name for minimum points and maximum points on a function or a graph. Okay, so for example, if I look at this graph like this, okay, and the graph continues on in that nature. You look at this graph and you see, bumps just like this. This particular graph has one, what I'm going to do? I'm going to make this go up a little bit higher. There we go. Okay, it has 1, 2 max. Okay, and it has a min. Now, okay, so it's got 2 max and 2 min. Now, a maximum point, it occurs at the x value. All right? But the maximum value is a y value. All right? Okay. I need to do an example here. Let's just make one up. Here we go. Let's say that I have I've got some sort of a polynomial function, and we need to see what its maximum and minimums are. Well, we're going to type in, let's say, f of x equals x to the 4th minus 7x squared plus 6x. All right, so we take our graphing calculator, okay, and we're going to type that into our calculator right here, y equals. Okay, clear out our last function, and we're going to have x to the 4th minus 7x squared plus 6x. Oops, and I was not paying attention, and so I put it all up above. Don't forget to go to the right. Okay, and I'm going to graph that function. Can't see it because I had used it, so I'll do zoom. So once it's finished, thinking over there, zoom 6 will get us just a standard window, okay? And that is my graph right there. Now it looks like I've got a little maximum point there and a minimum point, but it also looks like I might have something going on right down there, but I can't really tell, so I'm going to have to change my window. And it looks like my y values need to go lower. Okay? My x min and my x max wasn't really wide, but my y min needs to be maybe at negative 15. And it goes down, up, and again. Wow. Okay, it still looks like we did not get there yet. Might have to go down a whole heck of a lot more. I don't need this up there either, so we'll change that. My y max probably only needs to be to 5, but let's try negative 25. Okay, here it comes down, there it is, and then it goes up and then down again. Okay, so for the sake of this particular graph, it looks as though I have 1 max and 2 min. Okay, how do we find them? Okay, the way that we find them is, we're going to start with the maximum point. I'm going to start with that one right up there. Okay, on your calculator, you're going to do second, calc, second, calc, and you want to go down, we're trying to find the maximum. Okay, so you push enter. Now, on your calculator, it says left bound. You need, if this is the top point, your blinking cursor, see it right there? It just needs to be to the left of this point. The right and the left arrows move it. Okay, I am to the left of it, so I'm going to push enter. Then I'm going to go over to this side, and now I have to go to the right side of that maximum peak. So you push enter. We want to guess, so you push enter again. It says the maximum value. So for this one, the max value equals, and that's your y value, 1.3 2, 3, and what we're going to write down, I'm just going to move this for a second, I'm going to kind of turn it sideways, that it occurs at x equals 0.456 if we round, okay? So the maximum, this is where it occurs at, and that is the maximum value right there, okay? All right, that takes care of that one. Now we need to find the two minimum values. You use the same process, okay? You always go second calc. In this case, we're going to find the minimum. All right? And we'll start with this one over here. We have to go to the left of it. So you have to move over so you're just left of that low point. Push enter. You go again. You push enter and enter again. And you have a min value. Again, it's a y value. Equals negative 1.767. And it occurs at x equals 1.6. All right? Well, we have another minimum, and that's way over here. So we have to do this one more time. All right? Second calc. Okay, we're going to do the minimum. This time I'm going to have to move way over. Keep on holding it down. Oops. This time because of the words, I'm going to make sure that I can see it. Push enter. Then I'm going to have to go to the right-hand side. There, I see it. Enter. And it is right down there. You can't really see it because the numbers cover it, but that's what it is. So we also have a min value equal to, it's a y value again, remember, negative 24.057. But this occurs at x equals negative 2.056. Okay? Now, the only other thing that we want to talk about, if we look at this graph, is we've got these two words up here in the beginning. You see where it says we wanted to find local extrema and absolute extrema. Okay? Well, in this particular graph, if we stopped the graph right here and here, so that it looked on my paper like this, like I would actually stop it. Okay? And then it came up and it crossed and then it went down again. And I stopped it here and I stopped it right there. If I did that, this is called a local and absolute max. Okay? That's because, oops, sorry about that. That's because in this graph right here, that is the only maximum point. In this local area, it is the maximum. This happens to be an absolute min. That's because in this whole graph, it is the lowest point. This here is only a local min. Okay? It would be as though I wanted to find the tallest person in my pre-calc class. Okay? And we would say that it happens to be, Brandon's pretty tall. So he's the tallest person in my pre-calc class. So locally, he's got the maximum height. But then if we go to the entire school, we might have to stand him up against, let's say, Mr. Fensky, who is very tall. So in the school, Brandon is a local max for the classroom, but for the entire, or the absolute max in the classroom, but for the school, he's only a local max. Hope that makes sense. Okay. All right. So that takes care of that. All right. The next thing we need to talk about is symmetry. Odd, even, and neither. Okay. Symmetry is found two ways. Okay. It is found graphically, and it is found algebraically. All right. Graphically, that's first, if you're looking at a graph. If a function is even, then the graph is symmetric about the y-axis. Okay? So, for example, the x squared function. I have y equals x squared. If I folded the paper in half right along the y-axis, it would match up. Everything is symmetric, okay? That's how we know that it's even, okay? If something is odd, the graph has 180-degree rotational symmetry. What does that mean? That means that you can turn it upside down and it looks the same. A classic example of that is y equals x cubed. Okay? In y equals x cubed, you have a function that looks just like that. Okay? If I turn this function upside down, still goes in the same direction. Okay? It looks exactly the same. And that means that it is an odd function. So if you just look at a graph, you can tell if it's odd, even. Neither, then obviously it doesn't follow either one of these two rules. Okay? Now, you can also prove that they are even or odd algebraically. Okay, all right. So how are we going to do that? Well, the first thing that you would want to do is we need some rules. Okay, for even functions, if f of x equals f of negative x, then it is said to be even. For example, okay, let's have an example on this so that we can kind of understand. Let's try, if I have f of x equals x squared minus 3, okay? All right, that's what f of x equals. What does f of negative x equal? Well, you put negative x in for x. And remember that whenever you're putting in a negative variable or a negative number, put it in parentheses. Okay? Well, this equals negative x times negative x is simply just x squared minus 3. These two are the same, so this function is even. Okay? Odd. Odd means that f of negative x is equal to negative f of x. Okay? All right, well, let's see if we can figure that one out. Let's try another example here. Let's say that I have g of x equals x cubed over, okay, let's just say that. All right, well, first, let's put negative x in this function right here, okay? So, g of negative x. Let's put that in there. That equals negative x cubed over 4 minus, and then negative x squared. Remembering always to put it in parentheses. Okay? Well, negative x times negative x times negative x, that's going to give me a negative x cubed. Down here, this is going to be x. So that's what I'm left with. All right? Okay. What does negative g of x look like? Well, that just means the negative of x cubed over 4 minus x squared. Well, look at that. They're exactly the same, which means this function right here is odd. Okay? All right.